Welcome back to Around the World in 80 Telescopes, a live 24-hour webcast that is part of the 100 Hours of Astronomy project for the International Year of Astronomy. You're joining us at the European Southern Observatory headquarters near Munich in Germany as we visit some of the most advanced telescopes both on and off the planet. We're now going to go off the planet to Hubble Space Telescope, or rather to the NASA Goddard Space Flight Center in the U.S. Before we join them live, though, let's find out more about Hubble in this video.
It's our last shot. It's the fifth and final time. It's our last shot to extend Hubble's life and bring it to the apex of its scientific capability.
And we just have lots of things we want to repair on Hubble and upgrade on Hubble, and not a lot of time to do it.
And we're going to take up everything we can take up. And on this flight, it's about 23,000 pounds of hardware.
This is going to be a very exciting, complicated, and challenging mission. We have 7 brave astronauts who've made a conscious decision to risk their lives in order to continue the advancement of science that Hubble has begun. They're going to buy another 5, perhaps 10 more years of lifetime for this great telescope.
We've got a full plate of things to do. We've got major science upgrades that we're going to do, so we have 2 new science instruments that we're going to install.
We're going to put in the cosmic origin spectrograph. And this is, the fanciest spectrograph that's ever been put into Hubble.
COST plus Hubble together will be able to observe deeper across the universe than any other instrument of this kind has ever done before.
Well, we're going to install the Wide Field Camera 3, Hubble's new imager.
Wide Field Camera 3's discovery factor is about 10 times better than the current instruments that we have on Hubble.
One of the beautiful things about our new camera, the Wide Field Camera 3, is it will be capable of looking farther out across the universe and farther back in time and closer to the Big Bang than any other camera we've ever had on Hubble before.
We're also going to attempt 2 repairs of the 2 failed instruments on board Hubble, the Advanced Camera for Surveys and STIS.
ACS was inserted on Hubble in 2002. Before it died, it was the most heavily used instrument on Hubble. And STIS was our first black hole hunter, and it went on to do the first detection and chemical analysis of the atmosphere of a planet around another star. We want to keep on doing that kind of work when STIS comes back online.
And this will be the first time that we've ever done an in situ repair of science instruments, so this will be a big challenge.
In fact, there's 110 of these very small screws that we need to remove from the instrument in order to gain access to the board we need to replace. And in space, things float, and debris is a real issue.
If we're successful in repairing these 2 scientific instruments that have failed, it will be a real triumph for NASA engineering and will point the way toward our ability in the future to repair instruments in space. We want Hubble to last a while longer as a spacecraft. And since this will be our last opportunity to go service it, we're going to do things like change out all the gyroscopes that help Hubble point. We're going to put in a new fine guidance sensor. I say a new fine guidance sensor. In fact, it's a refurbished fine guidance sensor. It's one that's been on Hubble before and been brought back to Earth, refurbished it. So it's a used fine guidance sensor, but first class. We're going to change out our batteries. Never put in new batteries since Hubble was launched.
We have some insulation repair work that needs to be done.
We're going to install a new outer blanket layer called a noble, which is a solid. It's not a blanket anymore. It's a solid sheet that will go over the blanket.
And we'll also be installing a soft capture mechanism on the aft bulkhead of Hubble that will help facilitate a future mission to Hubble, primarily for the purpose of deorbiting it at the end of its useful life.
The 2 repaired scientific instruments working in tandem with the 2 new instruments that we're going to put on board Hubble in this mission will enable scientists to tackle some of the most profound issues facing modern science, not just astronomy, but physics today. This, in my mind, means that when the astronauts leave Hubble after servicing Mission 4, it will be at the absolute apex of its capabilities. It will be better than it's ever been before.
We're now going live to the NASA Goddard Space Flight Center. Hello.
Hello.
Hi.
Hi, guys. Could you please introduce yourself and tell us what you do at the observatory?
My name is Lisa Furtari. I'm an astronomical image processor at Space Telescope Science Institute, and I work on preparing press release images and images that get used for news releases.
I'm Dr. Mario Livio. I'm an astrophysicist, and I'm head of the Office of Public Outreach at the Space Telescope Science Institute.
Okay, welcome. We've been talking about observatories on Earth, and now suddenly we have moved out into space. So we can talk about your observatory's location, but tell us about Hubble's, maybe just tell people who don't know about where Hubble is in orbit around Earth.
So Hubble is in an orbit around the Earth. The orbit is about 550 kilometers above the Earth's surface. But that height is still such that shuttle astronauts can still get to it. And indeed, we are all looking forward to our upcoming servicing mission, which is supposed to happen on May 12 of this year.
Okay. And Hubble's used for all kinds of astronomy. Can you talk about some of Hubble's highlights, for example?
Of course. Hubble looks at almost everything that there is there, you know, in the astronomical universe. From extrasolar planets, these are planets revolving around stars other than the sun, through the lives and deaths of stars, to the expansion of the universe. And Hubble discovered, for example, that there is this dark energy that pushes the cosmic expansion to speed up, while we thought that the expansion should be slowing down.
Which is a fundamental part of our understanding of astronomy now.
That's right.
Go ahead, Mario.
It's, you know, arguably maybe it's the most challenging problem that physics is facing today is the nature of this mysterious dark energy.
Which makes up a lot of our universe. What's the percentage?
About 73%.
Okay. And you're working on Type 1a supernovas. Can you tell us more about that, especially our audience who might not be familiar with that term?
Yeah, these are stellar explosions. These are stars. These very compact stars. They are called white dwarfs, and they collect mass or accrete mass from a companion star, and then they explode in these very dramatic explosions. And these explosions are so bright that we can see them halfway across the universe, and as a result, we can measure, you know, how fast the universe was expanding billions of years ago, and compare it to how the universe is expanding now. And this is how we discovered that the expansion is accelerating. Okay.
And at the Space Telescope Science Institute, you had recently had a contest that really involved the public in the International Year of Astronomy. And I understand we are going to get to see the winner of the contest. Can you tell me a little bit more, maybe Lisa, also about the contest and how the image was chosen? Sure. And then we'll see the image.
Sure. In order to make the observations happen during the 100 hours of astronomy, we had to choose objects in the sky that the telescope was able to look at. They had to be bright enough, they had to be visible for a small enough amount of orbits. Our telescope goes around and we count our, instead of days or hours, we count how many orbits that the telescope goes around. So a moderate size of orbits for these objects. And so there were 6 targets that we gave the public. We gave them about a month to choose. And Mario, if you want to mention a little bit about the targets, what types of objects they were.
So the targets included one region where new stars are being born, and then 2 objects that we call planetary nebulae, which are stars in the end of their lives, stars like the sun. And then we had 3 objects that included galaxies. One was a spiral